Microcontrollers like the Arduino are already pretty small, as the name would imply, and most of the time, size isn't even really a concern. When you do need to go smaller, there are options like the Pro Mini or the Pro Micro. For a project I have coming up though, I need to go even smaller. Okay, maybe not this small. And in today's video, I'm going to show you the solution to my problem, the attiny 85. Measuring in at just 8.5 by 9 millimeters, you might be thinking that with it being so small, it must not be that powerful.
Right? Wrong!
This little guy can do just about everything any other larger microcontroller can do, and as an added bonus, since these are just small IC chips, they can be had for super low prices if you need a lot of them. If you need them fast, they can be had on sites like Amazon for around $3 a pop. I spent slightly more to get these set that comes with these little holders that make life a lot easier. If you're willing to wait, however, you can get them from a site like DigiKey for less than $2. I'll have links to all of the options in the description down below. The biggest catch with the attiny is that there's no easy way to program it. A portion of the circuitry on other Arduino boards is actually just there to deal with communicating with the computer. The attiny gives up this convenience in order to be as small as it can be. Luckily, you don't need any kind of fancy programmer or special software to overcome this. All you need is an Arduino Uno, a breadboard, and 6 jumper wires. A little later in the video, I'll show you how I made this device that can easily plug into the Uno to make setting up to program the attiny even easier, and make it possible to get serial debug output from the attiny. But let's set up the circuit on the breadboard for now. While getting this all hooked up, I'll consider the end that has the little notch to be the top. The 6 wires we need to connect are 3.3 volts from the Uno to the top rightmost pin, ground goes to the bottommost left pin, the Uno's pin 10 goes to the top leftmost pin, the Uno's pin 11 goes to the bottom right, Uno pin 12 connects above that, and Uno pin 13 above that. With that all set up, everything else we need to take care of is on the computer. Before we can use the Uno to program the attiny, we have to first upload a special program to the Uno. We're going to set the Uno up as something called an ISP, or In-System Programmer. Luckily, the hard work of figuring all that out has already been done. Open up the Arduino IDE and go to Example, Arduino ISP, Arduino ISP. After making sure that everything is configured correctly for the Arduino Uno, we can press Upload and get the program onto it. With that done, there are only a few more steps until we are programming the attiny. The first thing we need to do is tell the Arduino IDE how to compile our code. Once again, here we are working on the shoulders of giants, and the particular giant who already figured this out for us is called Spence Condi, aka Dr. Azzy. The process for getting his work integrated into the Arduino IDE is thankfully super straightforward. Head over to File, Preferences, and then click this little button next to Additional Board Manager URLs. Copy the text of the link in the video description and paste it in here. With that done, we can click OK and head over to Tools, Boards, Board Manager, and search for attiny. You should find an option called attiny core. Click Install on that and wait for it to download. Once that's done, head back to Tools, Board, attiny core, and then click on attiny 254585, no bootloader. With that selected, we just need to check a few settings and then we are ready to upload. Make sure that in the Tools menu you have attiny 85 selected as the chip. In the section below that, called Clock Source, you can choose from any of the clock speeds labeled internal. The higher the number, the faster the clock, and for some applications this may be necessary. The trade-off to the higher clock speed is that it uses more power. I usually like to start at 1 MHz and work my way up. It is very important that you only use the clock speeds labeled internal. If you use any of the external speeds, you will need to get extra components to make it work, and won't be able to do anything else with the chip until you do. With that all done, everything else stays the same. Set your COM port to the port of the Arduino Uno, and set the programmer to be Arduino as ISP. 2 more steps and our code will be running on the attiny. Click Burn Bootloader, and the Uno should start communicating with the attiny. The bootloader only needs to be burned on brand new chips, or if you change the clock speed of the attiny. With that done, we can open a program to upload. I'm going to be using this basic Blink sketch, but most any code you would use on other Arduinos will work here. Instead of using the LED built-in pin, since the attiny does not have one, I'm going to be using pin 2. After making those changes, we can press upload and the Uno will be off to the races. When it's done, it might seem like nothing is happening, but if we connect an LED from pin 2 to ground, Houston, we have blinking. That's everything you need to get the attiny working, and now whenever the power and ground pins are connected, your program will run. That's not quite everything we can do though, and I'll show you 1 or 2 more tricks if you stick around. The first thing is getting serial communication set up. Right now, if we try to upload a program that uses serial to send messages for debugging, we get nada. This is because the connection between the Uno and the attiny is really just a one-way street. If we want to get serial working, we need to use something called the software serial library. This comes pre-installed with the Arduino IDE, so you just need to include it at the top. Serial works by defining one pin as a sender and one as a receiver, so we set that up here. I'm using pins 3 and 4, but you can use any two free pins on the attiny. On the Uno, there are two pins labeled TX and RX. These are the transmitter and receiver for serial data on the Uno. Whichever pin we said would be TX on the attiny should be connected to RX on the Uno, and the RX of the tiny should go to the TX of the Uno. With that set up, we can use serial just like normal in our program. We press upload, but there's still nothing on the serial monitor. That's because we need to tell the Uno it should act as a serial to USB interface. Luckily, this is super easy, and we just have to connect the reset pin on the Uno directly to ground. After doing this, we can open the serial monitor again and see our printout. It is important to note that when we want to program the attiny again, we need to disconnect the reset pin from ground. Otherwise, it will not work. With that, you can write all kinds of fun programs for the attiny. As a final step to make my life easier, I took a piece of perf board, some male and female pin headers, a switch, and a breadboard, and put this together. This setup makes it easy to quickly turn any Uno into an attiny programmer. The female pin headers on the sides of the attiny make it easy to test out circuits on the attached board without having to take it off of the programmer and then put it back on. As a final touch, I connected this switch between reset and ground so I can quickly switch between serial mode and programming mode. The next part is up to you. I hope you take this and make something really awesome. If you have any questions, leave them in the comments below. If you like this video, a like would be amazing, and subscribing will make sure you get to see how I'm going to use these attinys. One final thing, I started a Patreon. Currently, signing up will get you access to a members-only Discord and a shout-out in my next video. I have plans for higher tiers in the future, but we have to start somewhere. If you made it all the way here to the end, thank you. I hope you have a good one, and I'll see you next time on Make It for Less.